Today I'm pleased to introduce our work, dynamic hand signal recognition and prediction framework for crane operation using deep learning. Nowadays, the crane are essential tools in construction sites, especially for modular or prefabricated projects. And according to the standard operating procedures, the every moment of the crane must follow the instruction from the signalman. So that makes the clear and accurate communication between crane operator and signalman very important. But however, this current communication remaining the major safety bottleneck in the construction site. And the traditional way, like hand gesture, hand signal, and the two-way radios are vulnerable to failure because of construction noise, environmental obstructions, and busy radio channel, or even language barriers. And according to US statistics, there are 78 fatalities related to crane accidents each year, and 9 of them are directly caused by communication failure. So to address this kind of a challenge, we developed a wearable system. We called it a hand clamp. It has two main parts: one pair of gloves with multiple sensors, and central unit with two balls, one Arduino, one Raspberry Pi. And the main workflow is in training process, the data from the sensor on the glove are go through the reshaping, data filtering, and auto labeling. Then they will be used for training a recognition model. And we can, after applying normalization, the data are used to train a prediction model. And after training, the model weight file are stored in the central unit. Then, so that in real-time operation, the gloves keep sending sensor data to the central unit, and the deep learning model running in the central unit can recognize the gesture, then generate the correct signal for operator. And in the gloves, we placed 3 flex sensors on the thumb, index, and the middle fingers. These 3 sensors for capture the bending or extension status of fingers. And we also attach the army on the back, which is for capture the overall movement of the hands, the orientation, rotations, everything. And all these data are transmitted to the central unit wirelessly by Bluetooth. And we have 2 boards on the central unit. One is Arduino, which is only for data processing, and Raspberry Pi there. And we run in deep learning model here. And the entire unit is for signalman. It can be attached or mounted on the signalman's belt or his vest. And as we mentioned several times about data processing, what we did here is we combined 5 time steps of sensor data to form a new samples, which can represent or describe a dynamic hand gesture. Since lots of hand signal are dynamic, keep moving, so we don't rely on the absolutely sensor value. The change over time matters more than just a single a sensor snapshot. And as you can see, for stop from the dynamic gesture, you can see the fluctuation of the gyroscope, and also for the other gesture shown there is boom down, full stop, while the finger keep bending, and you can see the fluctuation of the flex sensor. So to fully leverage our dynamic data structures, we designed a hybrid CNN long short-term memory model. It starts with two like parallel branch of CNN, which will extract features of the sensor data. Like it. The first one is a smaller kernel, which can get the local sensor patterns, and the other one is a little bit larger kernel, which can extract temporal informations. Then we combine them to form a rich feature pattern. Then we send these features to large memory layer, and in there, the model can learn how the gesture like involved. Also, again, not only the sensor data, the absolute value, just the screens, how it involves, that matter for us. And after that, it's some standard deep learning layers, then we'll can recognize the predefined gestures. For the results, our model can achieve over 98% on our validation data set with like 2,700 samples. And in real world test, we ask our volunteers to wear gloves and perform the gestures we required, and of course, including all the predefined hand signal for creams. And we achieved more than we achieved 95.272% accuracy overall. And for prediction side, we can predict the small sensor data directly, and then use the predict data, move this predicted data to the model for get signal trends ahead. And the predict data is part of the ground truth with accelerator and the sensor, the R-square scores more than 1. And for gyroscope, since it changed a lot over time, the score is a little bit lower, but still close to 0.8. So it's effective. So to summarize what we achieved, we have a real-time gesture signal recognition system. It's variable, practical, and our hybrid deep learning model can achieve more than 1% accuracy for the frame signals. And our prediction model can provide early signal trends, especially for stop. This is very important. It's not only for safety, it's also according to efficiency. Since the operator know when to stop ahead, so they move their handle or controller slowly, can reach the position more accurate without too many adjustments. Yeah, for the future work, actually, after the submission, we did do a lot of job to make it more practical. We have already convert a prototype to a real product that for ready for market. As you can see, the gloves, all the components are covered by 3D printed pieces for protection purpose. And we developed and we finalized the design of the central unit, which is a small black box. For easy to use, for easy and safety to use for signalmen. And we also developed a display unit, which can showing visual and audio warning for the operators. And we have two versions. So for signal transmission, the left one is for embedded system is using LoRa. The right one is using 5G. It's our mobile version. And we also conduct several field tests to make sure our system is stable and reliable, and also the transmission range. In our test, we can achieve almost 200, and in some tests we the maximum range for transmission is more than 400 meters. Yeah, for more details and our demo videos on YouTube or LinkedIn, please scan this QR code for our company. Yep, thanks for your attention.